Hello students, today we are going to discuss some more examples based on 2D elements, means plane areas. So we are starting lecture number 17 now. Let us read the example number 15. Find center of gravity of a lamina shown in the figure below. Lamina means area, 2D element. Here you can see how many parts in the example. This is the part number 1, triangle, right angled triangle. This is the part number 2, which is a square. And from the square we have to cut this semicircle, means part number 3. So part 3 semicircle will be subtracted from the addition of these two parts. Okay, so this is the variety of the numerical that we have to subtract the third part. Okay, so let us start the example. Now first of all, check the dimensions of the triangle. Here the base of the triangle will be 200 mm and the height of the triangle is given as 100 mm. So this is the triangle. In the part 1 triangle, we can find area is equal to, according to formula, 1/2 base into height. So 1/2 base into height means base 200, height 100, answer will be 10,000 mm square. Now for the x1, we have to draw axis first. So according to the rules, from the bottom x-axis always passing there, and from the extreme left of the figure y-axis passing there. Now CG of the triangle is somewhere over here. What is the formula? Formula is, from the height of the triangle it is base by 3, but we are calculating reverse. So from the y-axis this CG is at a distance of 2/3 of base, means 2/3 of this 200 is equal to 133.33 mm. Now again calculating y1. So from the bottom axis, means x-axis, the CG of the right angle triangle is at this distance. This distance is actually h by 3 according to formula, plus we have to add this 200 mm to reach up to x-axis. So total distance will be 200 plus h by 3 means 100 by 3. So 200 plus 100 by 3 is equal to 233.33 mm. So it is the CG of the part 1 triangle. So hence part 1 triangle is completed. Now let us check the part number 2. In the part number 2, we can see it is a square of side 200 mm each. So square is having area side cross side, means 200 cross 200 is equal to 40,000 mm square. Now let us talk about CG. CG of the square will be exactly at the center, at the midpoint. By checking the axis first, from the bottom it is x-axis, from the left side it is y-axis. So from both the axes, this distance is half of 200 and this distance is also half of 200. So x2 is equal to 100 mm as well as y2 is equal to 100 mm. So basically it is the calculation of square a2, x2 and y2. So values are available. Now let us talk about the part 3 semicircle. Now what happens with the semicircle? In the semicircle, the base is a diameter 200 mm, so radius will be 100 mm. So according to formula, area of the semicircular part is equal to pi r square by 2, putting down value of radius as 100 mm. So we will get 15707.96 in your calculator. Now talking about x3 and y3, so according to formula, where is the x and y coordinate of the CG? From the bottom and from the left axis. According to formula, CG of the semicircle is over here and this distance is actually y3, which is as per the formula 4r by 3 pi. So it will be 4 into 100 by 3 pi. Answer will be 42.44 mm. While talking about horizontal coordinate, means this distance is itself a radius of the semicircle, which is 200 by 2, means diameter by 2 is equal to 100 mm, which is the radius. So these are the calculations of part 1, 2 and 3. Now let us calculate its center of gravity, means x bar and y bar. Let us see where is the x bar and y bar. You can see in the next page, this is the calculation of x bar and y bar. Now as per the formula, some changes are there in x bar and y bar. We can see in the figure that semicircle should be cut out from the total lamina. Means in the formula x bar is equal to a1 x1 plus a2 x2, but the third part is minus, so minus a3 x3. Similarly in the denominator a1 plus a2, but the third part is minus a3. By replacing all the values calculated earlier, we can get the answer of x bar as 109.72 mm. So it is the calculation of x bar. Similarly, we can calculate y bar also. In the same manner, y bar formula will be a1 y1 plus a2 y2, but the third part has to be subtracted, so it will be minus. So a1 y1 plus a2 y2 minus a3 y3. Similarly, in the denominator, it will be a1 plus a2 minus a3. So answer is available to you. Now y bar is equal to 165.24. So these are the calculation of x bar and y bar. Hope you are getting the method very clear now and your practice is enough now. Let us see one more example of similar type in which one part is to be subtracted from the formula. See the next figure. It is the most important example in which find CG for a plane area as shown in figure. You can see the numbering. This is the part number 1, means full rectangle. This is the part number 2, means triangle. And this is the part number 3, semicircle, which is to be cut out. So part 3 semicircle will be negative. Okay, let us see the axis first. From the bottom of the axis, from the bottom of the figure, x-axis will be passing, and from the left side of the figure, y-axis will be passing. Okay, so now we have to calculate part 1 rectangle first. Let us check the rectangle part, in which area is equal to this height 300 and this base 400. How it will be 400? See this 100 and 150 is the radius of semicircle, though this is 150 plus 150, 300 total. This is total 300. So 100 plus 300 will be 400. Okay, again repeating, this is the x-axis, this is the y-axis, and area is equal to this 400 into this 300. So answer will be 12,000 mm square. Now where is the CG of the rectangle? CG of the rectangle is always at the midpoint. So from horizontal it will be 400 by 2 and from vertical it will be 300 by 2. So 400 by 2 gives 200 mm and 300 by 2 gives 150 mm. Now let us check part 2. Part 2 is a right angled triangle. So its CG will be somewhere over here. Horizontally b by 3 from the height and vertically h by 3 from the base. But we have to calculate it from x-axis and y-axis. Let us check the distance from y-axis up to CG. So this will be 400 plus base by 3 means 200 by 3. So 400 plus 200 by 3 will be 466.67. What is y2? This is y2, means 300 by 3 is equal to 100 mm. So it is basically the calculation of triangular part. Let us see part number 3, semicircle. Before that, we are drawing axis again. So this is the x-axis from the bottom of the figure. This is the y-axis from the left side of the figure. Now let us check the semicircle part, in which area is equal to pi r square by 2, means radius 150, so pi into 150 square by 2 will give this answer. Now where is the CG? CG is somewhere over here. From the x-axis it will be 100 plus radius. So it will be 100 plus 150, 250 mm. Now vertically measuring this distance is according to formula 4r by 3 pi. So 4 into 150 by 3 pi will give this answer 63.66 mm. So these are the calculations of part 1, 2 and 3. But remember that part 3 will be subtracted from the calculations. So let us see the calculation next. This is the calculation of x bar and y bar. You can see in the both formula, part 3 is subtracted from the addition of part 1 and 2. So what is the formula for x bar now? X bar is equal to a1x1 plus a2x2 minus a3x3 upon a1 plus a2 minus a3. Replacing all the values as found out earlier for the part 1, 2 and 3, we will get the answer of x bar is equal to 254.36 mm. Similarly, formula for y bar is equal to a1y1 plus a2y2 minus a3y3 upon a1 plus a2 minus a3. By replacing all the values calculated earlier, we will get y bar is equal to 163.53 mm. So g x bar y bar is equal to x bar and y bar means 254.36 and 163.53 mm. So basically these are the formulas of x bar and y bar, and today's numericals are based on the subtraction of the third part. So hope you are getting the practice now. We will conclude this topic in the next lecture and start another topic. In the next lecture, we will take some tough examples, 1 or 2, and we will start another topic. This chapter is near to end. So let's meet in the next lecture to conclude the topic. Till then, do practice at your home, and goodbye students. Thank you.